Hi folks, I'm early physics teacher at Dopu Foreign Language School. In this video, I will explain radioactivity. We will do one question from Cambridge AS Physics. In this video, we will explore beta plus decay and also we will study how to determine the charge on a hadron if its composition is given to us. Let's try to answer part A1 now. So in this question, it is given to us that it is beta plus decay because this nucleus decay by emitting beta plus particle. And this equation is given to us, but this equation is not complete. And we need to find out what is proton number and what is nucleon number of nucleus X. So first thing we need to understand what is beta plus decay. So let's try to find out what is beta plus decay. So let's say we have a nucleus X and this nucleus has atomic number that is Z and it has mass number that is A and it decay by beta plus, by emitting beta plus. So first of all, let's complete this equation. So atomic number decreases by 1 and mass number does not change if it is beta plus decay. So if we have understanding of this reaction, so then simply we can complete this given equation. So here is complete equation. You can see mass number is 35 for this particle X and atomic number is 17. Now we need to understand what is proton number. Proton number is in fact equal to atomic number. Atomic number, or simply we can say is Z. And nuclear number in fact is equal to mass number. Mass number, or simply we can say is A. So what is proton number? So proton number is simply this. So this is Z and mass number is here. This is A. So we just need to plug in these values. That's all for this part. So here is our final answer. Proton number is equal to 17 and nucleon number is equal to 35. Part A2 is quite straightforward one if we have understanding of beta plus decay. So here is the equation and part B is simply asking us what is name of particle Y. So here is the particle Y. So what is name of this particle? So simply this is electron neutrino, but sometimes it is little hard for students to find out is it electron neutrino or is it electron antineutrino. So the way you can remember this one is if this particle, let's say this one is antiparticle in this case, so this is antiparticle of electron, we also call this is positron, and this one has to be neutrino and vice versa, neutrino. So this particle, because this is antiparticle, so this is neutrino, it is not anti-neutrino. If this particle was electron, for example, then this has to be anti-neutrino. So this is what this question is asking us. So here is our answer, electron neutrino. For part B, it is given to us we have a hadron and this hadron consists of 2 down quarks and 1 strange quark. What we need to find? We need to find the charge on hadron in terms of the elementary charge E. So how we can answer this question now? So we have read this question, so we know what is given to us and what we need to find. So how we can find or how we can answer this question now? In order to answer this question, the first thing we can write down is what is the composition of this hadron. So a hadron has 2 down quarks and 1 strange quark. So we need to find the charge. So first of all, we need charge on each quark. Charge on each quark. So this is first thing we need to find out what is charge on each quark. This last step, we just need to add all charges on single quarks. As you can see here, I have already written for you the charge on each down quark is equal to this, and the charge on each strange quark is equal to this, and this charge is in terms of E, means this is in terms of elementary charge. And also I wrote for you here the hadron composition, so easily you can see here it has two down quarks and one strange quark. So here, the last step, you can see the chart. What I did here, I simply added all these charges, mean all the charges on quarks, and finally we got this answer. And so this is the charge on hadron. If hadron has two down quarks and one strange quark, and this is the procedure you have to follow to find the charge on any hadron or any other particle if its composition is given to you. Same steps you have to follow. Let's try to summarize the main points from today's lesson. So first thing we need to understand is beta plus decay. So this is the key concept in today's lesson. So in beta plus decay, we have discussed that if we have a nucleus that has atomic number Z, mass number A, let's say this is our beta plus particle, or it is positron, we also call this is positron, and here is an other particle, this one is called neutrino. So if this is beta plus, so atomic number decreases by 1 and mass number does not change. So it is very important to remember the names of these particles. Most of the time they will ask you about the names as well. So this particle beta plus is in fact is positron, and this is in fact antiparticle of electron. So antiparticle. So this is antiparticle of electron. So we also call this one positron. And this particle, we also need to remember that this particle is electron neutrino. Sometimes they will ask you the name of this particle. So this is electron neutrino. And also we have to be very clear, just one more point, this was not covered in this question, but we need to understand as the atomic number decreases by 1, so what is happening here? In fact, atomic number decreases by 1, it means one proton changes into neutron if it is beta plus case. So this thing you have to be very clear, and maybe in next question or next time they will ask you about this. And the last thing we discussed was how to find the charge, of a quark if its composition is given to us. So the process is very simple. First of all, write down what is composition of the charge, means not composition of the charge, in fact I mean that composition of the hadron. So you can write down, let's say the composition is two up quarks and it has one down quark, let's say hadron. So this is in fact is proton. So how we can find the charge on this particle? So simply we can find the charge on this one by adding the charges on each individual quark. So simply you have to add the charges on each individual quark like this. You just need to plug in these values and we can find the charge on any hadron. So this process is kind of typical, or it's very common every time. You just need to follow these steps and you will find your final answer. So that's all for today's video. And I hope that you have better understanding about beta plus decay, and also you are quite clear about how to find the charge on hadron if its composition is given to you.